Okay, so number 39, a ball player catches a ball 3.4 seconds after throwing it vertically upward. With what speed did he throw it and what height did it reach? I'm going to show two ways to do this. The first one, we're going to look at the entire path. So I think it's kind of neat that we can do these different ways. Once you do enough of these problems, you'll start to see that they're all kind of the same. Anyways, the key is identifying your values and making sure that you're choosing the right matching values, right? So if you're choosing starting velocities and final velocities, those need to correspond to the right times that you're looking at. You'll see an example of that right here. Okay, so in this first one, I'm looking at the entire trajectory. Okay, the entire trajectory up and down took 3.4 seconds. Acceleration is always downward, negative 10 meters per second squared, right? So we're calling up positive and down negative. Okay, what else do we know? Well, if we're looking at D actually represents the displacement. Okay, the displacement in this example is 0. Okay, it starts here and it returns to the same place that it started. We also know, what else do we know? Well, we don't know anything else. So we want to find that initial speed, right? It says with what speed did he throw it? So we're going to do the first part there. All right, so we have these four values. So which formula do we want to use? The one without V final, right? So this one. So we get D equals VI times T plus 1/2 AT squared. Okay, so D is 0. And now we're going to solve for T. Wait, what are we solving for? We're solving for VI, sorry. So VIT equals okay, get those on different sides. The T divides out. So we get, whoops. All right, and we know acceleration is negative 10. We know time is 3.4. So, what speed did he throw it? Let's see. Opening up the calculator. We get 17 meters per second. Okay, and what height did it reach? So now we need to break it into a piece here. Okay, there's a couple things we could do. We could divide this time by 2, right? We could divide the time by 2, and that would, we could put that back into the formula, and it would give us this up here. We also could break it into half. So we could look at it like this. Now V0 at the top is always 0. A is still negative 10 meters per second squared. Now we want D, and as I said, we're going to divide that time by 2, right? So this came from 3.4 seconds divided by 2 equals 1.7 seconds. Okay. All right, so now, again, which formula are we going to use? Let's see, we want the formula that has these 4. So the one that doesn't have V final, so, oh, that's that same one again. Okay, this time our V initial, or, sorry, I wrote V0 here, so just the notation thing, right? These mean the same thing, V initial and V zero. I'll try to be consistent, but you can see here I'm not being consistent. But just be aware those mean the same thing. So that initial value is 0. We get 1/2 AT squared. Acceleration is -10, time is 1.7. So if we put that into our calculator, we get 14.45 meters. So this thing went 14.45 meters high, and it reached 17 meters per, or sorry, it was thrown at 17 meters per second.